now we're going to kick off with Neal Ford. Neal Ford's a distinguished engineer at ThoughtWorks, and one of the big things that we very often forget about when we use AI coding assistants and coding agents is the long-term maintenance, the long-term debt that we really add in when we are rapidly building with AI. And so Neal's going to give us a great insight into fitness functions or fitness function-driven architecture and making sure we think about the longer-term design, the longer-term architecture of the applications that we build. So with that, Neal, it's a pleasure to welcome you to AI Native DevCon.
Thank you very much. Thanks for having me. So I'm going to talk about the looming disaster of code quality and sustainable software a little bit, but mostly what I'm going to do is tie together a bunch of things that exist out in the world. So let's first start talking about this concept of an architectural fitness function. This is something we defined in the book Building Evolutionary Architectures, originally back in 2017. And this is sort of like a unit test, but for architecture capabilities. We want to verify that as we build our architecture that we don't break stuff. And so our definition is any mechanism that gives you an objective integrity assessment on some architecture characteristic. But that's how these are different than something like fitness functions or than unit tests, because these have a much broader scope. Software metrics, for example. I will actually give you my preferred metric for detecting AI slop in your code base from an architecture standpoint a little bit later in this talk. Code level metrics let you assess things about your architecture. Unit testing libraries, which I'll talk about, that are specialized for this. But we also use things like monitors and observability. These are all things that we need to know about architecture, because architecture is not just our code base, it's also data and integration architecture and all the other things that go into our ecosystems. Chaos engineering is a perfect example of this idea of an architectural fitness function. And over time, we've seen more and more of these mechanisms come about. And I'll show you how that applies in the real world kind of scenarios. The second part of this is it needs to have an objective integrity check. So that's the way you verify something, is you come up with an objective value for it, and then it's either true or false, or it's a number, or so that's how we verify things. And we also look at not just code, but also things that impact architecture like data. If we're in a distributed architecture and splitting data, we would still like to have referential integrity between our databases. That's an architectural concern if we're in a distributed architecture. And so it's broader than just code bases. I typically at this point want to show you a very simple example of one of these things, but this one is particularly apt. Cyclic dependencies. If I'm writing a software system that composes of components, and most of them, if they're any complexity, have components in them, one of the things I want to try to avoid are cyclic dependencies. That's where one component references another component, which references a third one, which references the original one again. The reason this is bad is because now if I reuse one of these components, I have to take the whole rat's nest with me. And if one of these is also cyclically bound up with another one, then now I'm having to pull this entire tree of relationships. If I try to reuse something, this is generally considered an anti-pattern in software architecture. But it's subtle, because if I have one of these in my code base, it's not a big deal. If I have 100 of these in my code base is a piece of trash. And so there's a tipping point here somewhere where it gets bad enough to become really bad. The problem though is that developers, as they're coding along and their IDE pops up a dialog and says, you want me to auto-import that for you? They never read that dialog. They just swat it away and keep doing what they're doing. Most of the time it's okay. Every once in a while it's this. And even worse, unless you explicitly tell your agent, don't do this, it's going to do this all the time, because it doesn't know that this is not something you should be doing. This is just something that it wants to do. How do you prevent this from happening? Because I can't spend all of my day going through every line of code that's been created to make sure nobody's created cycles in my code base. You create an architectural fitness function for this. This is using the tool called ArcUnit that understands dependencies in code bases. I wire this into my continuous build, and whether I write this code or another human writes this code or a machine writes this code, I don't get cycles in my code base anymore. This is a way that I can create more sustainable code bases by building guardrails around the important parts of my architecture that I want to preserve for long periods of time. Fortunately, there are a lot of tools and frameworks that have come out in this space. ArcUnit is a library in the Java world. That's the code I just showed you is ArcUnit. But there are also a couple in the .NET world. This is ArcUnit Net and NetArcTest, both of which work in the .NET world. Here is PyTestArc, which is from the Python world. This is ArcUnit TS in the TypeScript, JavaScript, ECMAScript world. And here is ArcGo in the Go language world. And so pretty much all the platforms, technologies, and frameworks you can think about have tools that let you write these architectural fitness functions to validate that the architectural concerns in your code are actually working correctly. Okay, that's fine and good, but limiting. Because here's the thing I really want to write a fitness function for. I have microservices. I have an orchestrator, order placement, payment, and inventory. And the way I've designed my architecture, I don't want the domain services talking to each other because the orchestrator is holding on to the state of my workflow. And if they talk to one another, my state gets out of whack and bad things happen. Where can I write my ArcUnit fitness function to validate that the domain services only communicate with the orchestrator? Where's the tool or the framework or library I can download to do that? Unfortunately, that does not exist, nor can it exist. The problem when you get into architecture is variability. What have I written these things in? This is microservices. These may all be written in different platforms or technology stacks. So who knows what these things are written in? How are they communicating with each other? Is it REST? Is it SOAP? Is it message queues? Is it gRPC? What kind of database are they? It's so many variables. There's no way you can find a pre-built framework to do this for you. And so a lot of architects just look at this and just give up hope. But that's the wrong approach too. The book that we're writing right now is a book called Architecture as Code, which is encouraging architects to treat their software development ecosystem as if it were a code base. And one of the mantras in our book is, what data do I need and where does that data live? So if I ask this question about this particular problem, what data do I need? Well, I need to know who these domain services are talking to. Where does that data live? It lives in log files that they can produce, and I can guarantee that they produce. And so my fitness function looks like this. For each one of those services, import the logs for the last 24 hours, and unless they're calling the orchestrator, they're cheating, yell at them, they violated my fitness function. This is actually written in Ruby, which is one of my favorite little scripting languages. And in fact, most of these architecture fitness functions are not written in the platform or technology stack that you're implementing your solution in. They're written in little tiny scripting languages that aggregate data that's already laying around in your ecosystem that you're just not taking advantage of. Most of these fitness functions are 10 or 15 lines of code that's just piecing together some things that are already there. So what we're doing in architecture as code is looking at all the ways that architecture intersects with the software development ecosystem and trying to define those intersections with fitness functions. Architecture and implementation is obvious because we have to implement architecture in code to actually make it work. But we all can look at architecture and engineering practices. One of the problems we perpetually have is I need to make a bad choice. I've got to choose between a mono repo or repo per service. And the problem is they both suck, but they both suck in different ways. Using this, you can find a way to write code that mitigates the negative side effects of the choices you have to make anyway. That's an example of engineering practices. You can build intersections around things like team topologies or integration architecture or the enterprise, which I'll talk about in more depth in just a second. And of course, generative AI and infrastructure and data and things like the business environment. And in fact, let's look at an example of this intersection with data and architecture. the architect says, I've decided to split the database into 2 domain databases for better fault tolerance, better change control, and better scalability. The product owner says, great, but make sure we don't lose any trouble tickets, and that both domains have the same tickets. Where's this information documented? I just recently did a workshop, and the universal answer to this question was in some spreadsheet somewhere. And alas, that is probably true. Some spreadsheet somewhere holds onto this information. But how are we verifying that? So here's the scenario. I have customers and I have tickets, and I've had to split the database apart for architectural reasons because I want better fault tolerance and scalability. But now I need to make sure that all the tickets have corresponding customers because I don't want to have tickets without a customer. That doesn't make sense. So what data do I need and where does it live? What I'm going to do is go to this database and grab the set of customer keys from there, go to my ticket database and grab the ticket foreign customer keys there, and when my queue has no messages pending, in other words, it is at rest, assert that TC is a member of C. In other words, assert that there are no tickets in that database that do not exist in this database. I am now verifying the referential integrity between these 2 databases as if it were a single database, but doing it at the architecture level because I need a distributed architecture. This is an example of the data intersection of architecture as code. And this works great. We've done this a lot. Problem is, it's hard to do at an enterprise scale. So this works fantastic. We've been doing this for years at the application level. But now I want to talk about something that I'm calling a meta-bounded context. When we talk about software architecture, we talk about bounded context all the time as it pertains to the domain that we're writing, but projects have a meta-bounded context, which is the way they've implemented stuff like this. Highly specific to this project because I have details about the databases that are used in this project that I'm implementing for this fitness function. Hold on to that thought for just a second because now I want to touch on this intersection of architecture and the enterprise. We have a defined role called enterprise architect who does this intersection with architecture and enterprise. And in fact, there are a bunch of different things that enterprise architects end up doing in terms of software architecture, including things like global governance, global code quality governance. That's what I'm after here. This, by the way, normalized distance from the main sequence. If you're looking for one single metric that identifies AI slop in your code base, that's it. It looks for code that has been built by brute force with a lack of abstraction and too much implementation details, scores poorly on normalized distance from the main sequence. So just by the way, if you're looking for actual metrics that find AI generated code, that's it. And this is the only thing that we've really seen a lot of success with because as a group of enterprise architects, I would like to govern a lot of stuff in my ecosystem. But this is really the only kind of stuff we found that is universally useful, these kind of holistic governance, code quality things like cyclomatic complexity. No code base benefits from having overly complex code or poorly structured code. But the problem we've run into is we'd like to be a lot more hands-on. In fact, our largest global client has within their enterprise architecture group a role called an evolutionary architect, and they are going around implementing fitness functions within their ecosystem to try to govern things from the enterprise level. But there's a problem with that. We've been doing this since 2017, 2018, and we discovered the issues with that fortunately Agentic AI has come to the rescue for. So let's talk for a second about architecture and agentic AI. and MCP. Before MCP, if I wanted to call something directly, I had to know exactly what that API was and know the details and the metadata and the format. MCP is like the best ever integration hub because it gives you a way to query capabilities or tools, etc. It allows you to wire things together in a much more generic way because you can query capabilities and come back and iterate on those capabilities and do things on behalf of them. The MCP primitives, which I'm sure you're familiar with, tools that are available that you can call and do stuff for, like database calls, resources like logs, file contents. This is where I get logs very often when I'm doing those kinds of compare logs in my fitness functions. I can do that through something like MCP because log contents are one of the things it can deliver. And of course, prompt libraries to let you piece things together within that MCP kind of universe. So let's talk about how this solves this problem. As an enterprise architect, I want to be able to write these kind of fitness functions because I, as an enterprise architect, want to guarantee that the projects I have referential integrity between the databases. Here's the problem. It's the meta-bounded context. Because as an enterprise architect, I'm sitting way far away from that application, and if I write this code and they change the implementation, it breaks. And that's the fundamental problem of trying to implement these far distance fitness functions is brittleness. Because to be able to do that, I have to pierce the meta-bounded context to get to the implementation details, and that makes it brittle. And that reduces its effectiveness, because if these things break a lot because of incidental reasons, you get frustrated with them and go, this is not worth the trouble. Don't want to do that anymore. That's where MCP comes in. Because enterprise architects can now, through the service mesh, which is the thing that generally executes all of these things, say, I want to validate referential integrity. The project itself can set up an MCP server inside their meta-bounded context that knows the details of how to do that and can offer this as a tool for the enterprise architects. I want you to validate referential integrity. When it gets that, it says, well, I know what that means. When Q is equal to 0, assert that TC is an element of C. But then, when the implementation changes, which it inevitably does, I need to add experts over there who also have tickets, who also have foreign key relationships between things. Now, the implementation of my fitness function has to change, but the intent doesn't. This is huge as empowering for enterprise architects to be able to state intent like this at the architecture level without having to know the implementation details of how things work and still be able to implement this kind of holistic governance across the entire organization. This having MCP as this ultimate sort of integration layer is fantastic because now it separates the intent from the implementation in a way that's very, very useful for enterprise architects. So could not have come along at a better time for us. And so mesh architectures like service mesh plus agentic capabilities plus fitness functions is what we're calling fitness function driven architecture, or alternatively, very ambitiously, 21st century enterprise architecture, because that's really what we're after here. Because what this allows us to do, and this is one other interesting use for AI, that's a sort of a bonus use here. As an architect, I design a lot of stuff. I design components around domains and relationships and dependencies between these components and put a lot of thought into this as an architect. This is what we do as an architect, is figure out coupling and cohesion around components, etc. But then I hand this off to a group of developers to implement it. And after it's implemented, I look at it again and I go, what? Ticket assignment disappeared at some point during the implementation, and customer registration's not there, and this new thing showed up that I never designed as part of my architecture, and all this chaos has occurred, and this is actually what got implemented. Despite my nice clean design, when I handed this to developers and schedule pressure showed up and things changed and I ended up implementing chaos like this, this idea of architecture as code, what this allows us to do is actually define things as code. Define our domains, define the relationships between them. This is our architecture as code, pseudocode, and then assert that classes are only contained within classes within those domains. This is the other use that we have found is quite useful for generative AI, the second L in LLM, because you hand it this pseudocode and tell it to produce me a fitness function in Java or .NET, and it will do so. And what this is, of course, doing is validating the directory structure. So you hand this to an LLM, and it will produce concrete fitness functions for you. This is nice because I can keep my rules in pseudocode, and then if I have a Java code base, or Golang code base, or a .NET code base, or a Python code base, I can generate all of the pertinent fitness functions for those that validate the structure as I write my code. Just like a building architect creates a plan for how the build of the room should be laid out and the relationships, like where plumbing goes, I can now, as an architect, define how I want things put together in my ecosystem. That is this idea of a fitness function-driven architecture, and it's a way to enhance collaboration between architects and developers to make sure that they are building the things that I actually want them to build. This is what we were referring to as fitness function-driven architecture, and it's similar to So fitness functions are like unit tests in that it allows you to verify things as we go along, preferably on each change, and it makes sure that we haven't broken anything that we're building on. Fitness functions are not like unit tests in that failures are placeholders for conversations about design decisions. As an architect, I build one of those things that say, here are the components I need, and then somebody builds a new component. That's not an error, that's a placeholder for conversation. I don't want to yell at them about it, I just want to know that it happened. And so architecture as code is really a fast feedback framework for anything that happened in architecture that I care about, let me know about it so that I can react to it. Fitness function-driven architecture is like test-driven development, that we both build things and constantly verify them as we go along. It's unlike test-driven development in that it is the mechanics for evolutionary architecture. It's not meant to cover every detail, just the important stuff. And this is really an important perspective. We're not trying to create an architecture police state here. We're trying to create an ecosystem where we can work within the context of a project and define rules at the enterprise architecture level that I really want to implement, but I don't want to get into details of how to implement that. Agentic AI is a really, really nice way to do that, and it gives us a way to build this kind of holistic governance in a way that doesn't create this sort of brittle breakage all the time. So very, very nice. More and more details of this coming out. In fact, we just published an article about this on the O'Reilly website, talking about these details. So much more of this coming in the Architecture's Code book, which should be out sometime later this next year. And that's it, 30 seconds to spare. Thanks very much.